Hi, welcome back to another Celltomic video, and today we'll be back on our chemistry video. So today we're doing part 2 of our mole series. If you haven't catch part 1, where we learn how to find mole using the Avogadro's constant and the mass, I highly recommend you to check the link below or click on the top right hand corner now to see that video. So in part 2 of our mole series, we'll be learning how to find moles in solutions. So finding mole in a solution usually takes place when we know the concentration of the solution. So the concentration is actually the relative amount of a solute in a solution. So the units in concentration is usually either gram per dm cube, which allows us to find the mass, and this is known as the molality, or we're given it in terms of mole per dm cube, where it allows us to find the mole, and this is the molarity. So you may be thinking, what is a dm cube? So a dm cube is actually a unit that represents 1 liter. So 1 dm cube is equals to 1 liter, which is equals to 1000 cm cube. So 1 dm cube is also equals to 1000 milliliters. So this is the conversion rate from dm cube to cm cube, or from dm cube to milliliters. And you will see why we need to know this later. So the first one, we're going to find mole using concentration when we're given in grams per dm cube. So from this formula triangle, we can see that concentration times volume gives us mass. So with the mass, we'll then be able to find the mole. And we have learned how to find the mole using mass in part 1. If you have no idea how to do that, I highly recommend you to go check part 1 first. So let's look at an example. So our example says that John added 100 cm cube of hydrogen fluoride with a concentration of 50 grams per dm cube into a beaker. How many moles of hydrogen fluoride are there in the beaker? The question also gives us the atomic mass, which will be useful for us to find the mole since we're going to find the mass of the hydrogen fluoride. First, we need to find the amount of hydrogen fluoride that is being placed into the beaker. So mass is equals to 100 over 1000. Okay, you may be thinking why we take 100 over 1000. Okay, we know that this here is the volume added. But this volume that's being added is in terms of cm cube. But the formula states that concentration is in dm cube. So we will need to first convert cm cube into dm cube. And to do so, we have to take 100 over 1000. And this is because, remember in our earlier slide, we know that the conversion from dm cube, 1 dm cube, is equals to 1000 cm cube. Therefore, for us to find 100 cm cube, we have to first take 100 divided by 1000 to give us this entire thing in terms of dm cube. Okay, so this volume will then multiply by the concentration, which is 50. And this will give us 0.1 times 50 equals to 5 grams. So now we know that 5 grams of hydrogen fluoride is inside the beaker, but we want to know how many moles are there in 5 grams of hydrogen fluoride. So if you have watched the first part, you know that mole is equals to mass over mR. So the mass is 5 grams and the mR is 1 plus 19. And where do we get the value? The values can be found here. So this is the atomic mass, or we can also find it in our periodic table. So this is equals to 5 over 20, and this is equals to 0.25 mole. So that is how we find the number of mole when we're given in terms of gram per dm cube. So now let's learn how to find mole when we're given in moles per dm cube. So same thing, concentration times volume will give us mole. This time it's mole instead of mass. So now let's look at the example. In this example, John added 50 cm cube of hydrogen fluoride with a concentration of 50 mole per dm cube into a beaker. How many moles of hydrogen fluoride are there in the beaker? Okay, so in this question, we have a different volume. Now it's 50, and the units are different. This is mole per dm cube instead of grams per dm cube. So now we can find the number of moles immediately since we're not finding mass. So mole equals to concentration. Concentration is 50 mole per dm cube. So times the volume. So the volume is 50 cm cube. But remember, we need to convert it. So to convert it to dm cube, we always divide it by 1000. So this equals to 50 times 0.05, which is equals to 0.25 mole. And that's our final answer. So this is how we find the number of moles when we're given mole per dm cube. So that's all we have today. So this is part 2 of our mole series. We're going to have one more part where we're going to see how to find the number of moles in gases. So remember to subscribe to our channel so that you won't miss the last part of our mole series. And remember to always stay curious.